I got some great news for you. So great for myself as well, because Andromeda, we can look at you now with the help of this big telescope that we have got. Say hi to this telescope, and now Andromeda Galaxy, you are not far from us. Yes, you are 2.5 million light years away. Now with the help of this big telescope, we are gonna look at you. Come on, I'll show you this telescope. We have got this telescope for our college. But of course, we'll be looking at the night sky with the help of this telescope, and we're gonna be looking at Venus. Of course, we looked at Venus with my small telescope as well. But what is so special about it is the magnification that this telescope is gonna offer. We will be looking at Mars, the red planet. I'm pretty much sure that it would look red, it would look clear with this telescope. Then what else we can look with this telescope? Yes, Jupiter with its rings. Yes, most of you don't know that there are so much of debris, surrounding Jupiter. It makes rings as well. But these rings are not so pronounced as the rings of Saturn. So we'll be looking at the rings of Saturn's. We'll be looking at Jupiter's moons. And what else? Yeah, Mars there. But what I'm most excited about is Andromeda Galaxy, because I'm really waiting for myself looking at Andromeda, because when I'll be looking at Andromeda, you know what I'll be looking at? I'll be looking back in time, 2.5 million years back in time. And this is what I've discussed in my book as well. Come on, I'll show you. Here's my book. And here, over here, and somewhere over here, I've discussed this concept of time travel. And I've talked about it not as time travel, but time delayed travel. I've talked that if there is a planet in Andromeda Galaxy looking at us 2.5 million years back in time, same is true for us. Through this telescope, we'll be looking at Andromeda 2.5 million years back in time. So if there is a hypothetical planet there in Andromeda looking at us, they'll be looking at us 2.5 million years back in time, looking at the Ice Age, looking at saber-toothed tigers roaming about, looking at, the woolly mammoths and the primitive human beings, Homo sapiens, for example. Now, if there is a force X, again, if there is a force X, if there is this mysterious X force that can have a speed higher than the speed of light, greater than the speed of light, yes, time travel is possible, and I call it the instantaneous mode of time travel, and this is possible. The universe itself is expanding faster than the speed of light. If the universe is 13.8 billion years old, its total diameter is much more than that, which shows that the universe is expanding much faster than the speed of light. I do not call it a mysterious X-force anymore. I now call it something that is known. How can universe be expanding faster than the speed of light? Didn't Einstein say that the speed of light is the ultimate constant in the universe? If that is so, this universe should not have expanded faster than the speed of light. Now, coming back to the telescope over here, we have got different eyepieces. The eyepieces come over here. We get these lenses over here. It wraps. There is a mirror. If you can look down over here, you'll find a mirror at the back. It collects all the light, all the visible light. It focuses all of the light to the secondary mirror, and with the help of these eyepieces, what we can do is we can watch the galaxies, we can watch the planets. All we have to do is focus it. Once it is focused, first we get the targeting pod right. We get the star and the galaxy inside the targeting pod. There's a crossover here, and that point should be right there in the middle of it. Once it gets in the middle of it, we're gonna lock it here, and then we can start looking at the object that we are observing. So we've got the two lenses. One is the 10 mm And the second one is the 25 mm. This 25 mm goes over here. And then, yes, everything is gonna be crystal clear. So, no more waiting. We're gonna start the observations. Like, subscribe and support Adidas Cockpit.